You step off a platform at the Karman line. 100 kilometers of nothingness lie below. The sky is black. The earth is a giant curved marble. Gravity takes over. There is no wind, no sound, just a long, silent drop into the deep void. Falling is easy. There is no air to push back. Acceleration is constant. Speed climbs rapidly, 100 miles per hour, 500, 1000. The silence remains absolute. Oxygen levels are non-existent. Lungs collapse. Blood begins to boil in the veins. This is called the Armstrong limit. The body becomes a human popsicle in the shade and a toasted marshmallow in the sun. It is all quite unpleasant. Eventually, the void ends. The first few molecules of the thermosphere appear. They are sparse but fast. Impacting these atoms at hypersonic speeds generates heat, not a gentle warm breeze. We are talking thousands of degrees. Air begins to compress in front of the falling body. A shockwave forms. The skin starts to char. Clothing vaporizes instantly. The falling object is no longer a person. It is a streak of incandescent plasma. The atmosphere is acting like a brick wall. The sudden deceleration is violent. Internal organs shift. The spine compresses. Gravity is no longer the enemy. The air is now the enemy. The descent becomes a fiery plummet through a wall of dense gas. Most people worry about the landing. That is a mistake. The landing is the easy part. At this stage, the body is already a charcoal briquette. The concern shifts from survival to aerodynamics. A charred corpse is surprisingly aerodynamic. It falls like a very heavy stone. The descent enters the stratosphere. The air thickens. The plasma phase ends, but the heat remains. The body reaches terminal velocity. This is the point where air resistance equals the pull of gravity. For a human-shaped piece of carbon, this is about 120 miles per hour. The wind screams. It is a deafening roar of chaotic air. The friction continues to peel away layers of carbon. The shape of the object changes. It becomes a smooth, blackened pebble. The atmospheric pressure increases. The lungs, already ruined, are now crushed by the weight of the sky. The descent is now steady. The fire is gone. Only the wind remains. It is a long, boring ride down. The view is lovely if you still have eyes. Most people do not. It is very quiet again, truly. The plummet hits the troposphere. This is where the weather happens. The carbon pebble slams into a cumulonimbus cloud. It is like hitting a wet sponge at high speed. Lightning flashes. A stray bolt strikes the falling debris. This adds a sudden electrical jolt to the trajectory. The object zigzags violently. It is now a glowing, electrified piece of charcoal. The air is thick now. The terminal velocity drops slightly. The friction is negligible compared to the initial re-entry. The descent becomes a matter of simple geometry. The ground is no longer a distant curve. It is a flat, hard surface rushing upward. Forests, cities, and highways blur into a green and gray smudge. The wind is no longer a roar. It is a whistle, a high-pitched scream of air passing over the charred remains. The end is approaching. There is no parachute. There is no one to catch the debris. There is only the inevitable. Final collision. Impact occurs at roughly 200 meters per second. The physics are simple. Kinetic energy equals 1/2 mass times velocity squared. The body is small, but the velocity is high. Upon hitting the pavement, the energy must go somewhere. It does not go into a bounce. It goes into a crater. The impact creates a localized shock wave. A small plume of dust and concrete erupts upward. The carbon pebble is pulverized into a fine black powder. This powder is sprayed across a 20-foot radius. The sound is a sharp, metallic crack. It sounds like a gunshot magnified by 1,000. Nearby car alarms trigger. Pedestrians stop and stare at the new mysterious hole in the sidewalk. The temperature at the point of impact spikes for a fraction of a second. The concrete turns to glass. A small vitrified circle marks the spot where a human once stood at the edge of space. The dust settles. The wind carries the remnants of the jump away. The event is over. The physics are satisfied. The energy has been successfully transferred from a falling body to a piece of municipal infrastructure. It is finished. The tragedy is complete, but the paperwork is just beginning. Local authorities arrive to secure the scene. A forensic team analyzes the vitrified concrete. They find trace amounts of carbon and a very expensive melted watch. The cause of death is listed as multiple blunt force trauma. The insurance company reviews the policy. They find a specific clause regarding unauthorized space travel, since the jump occurred outside of a regulated flight path. The claim is denied. The grieving family receives absolutely nothing. In the end, jumping from space is a very efficient way to travel. The trip takes only a few minutes. The cost is high, but the speed is unmatched. The only downside is the lack of a landing plan. This is generally considered a flaw. You should probably stay on the ground. It is safer. Subscribe to the What If Club for more ways to accidentally vaporize yourself using basic physics. We have plenty more.